Yes, it's my great pleasure to welcome as speaker a new faculty member in the Department of Environmental Health Sciences. Some of you probably do not know that Dr. Lara Cushing, who is an assistant professor, is also filling the Jonathan and Karen Fielding Presidential Chair in Health Equity endowed position. She has a highly diverse background. She has a Bachelor of Science degree in Molecular Environmental Biology, a Master of Arts degree in Energy and Resources, a Master's of Public Health and Epidemiology, and a PhD in Energy and Resources, all from the University of California at Berkeley. So she attacks research problems from a very unique perspective, and I'm glad to welcome her presentation. So Lara, take it away.
Thank you so much, Shane. I'm going to share my screen. Can everyone see my slides?
Yes.
Okay. Well, thank you again for inviting me to present, and to everyone tuning in. I'm going to be talking today about fracking and flaring. If you don't know what those things are, don't worry. I'm going to define them in a minute. But I'm excited to share with you some of our findings from a project looking at the health impacts of flaring from oil and gas development, and particularly risks to pregnant women and risks of preterm birth, and also talk a little bit about the environmental injustice implications of oil development in the US. So I will certainly save time at the end for questions and answers, but if you do have questions as I go, I welcome you to either take yourself off mute and ask a question, or I'll try to watch the chat, and feel free to put questions there in the chat and I'll respond. Okay, so you know, usually when we think about the health impacts of oil, we think about burning the oil, right? Burning the fuels that we make from oil, like gasoline and diesel, and all the air pollution that results from that, and of course there is a large documented burden of disease globally associated with traffic-related air pollutants, and a lot of great research at UCLA on traffic-related air pollutants. What we think less about, I think, is kind of what happens before the oil gets to the vehicles and comes out the tailpipe, and the emissions comes out the tailpipe. And that is the whole upstream process of making our fuels from oil, including refining, emissions, hazardous air emissions coming out of refineries, where oil is turned into usable fuels, spills from pipelines and tankers and other means of transporting crude oil to refineries. And what I'm going to talk about today is the drilling process itself, and when this oil is actually taken out of the ground. Because there are pollutant releases and health risks all along this, this pipeline, if you will, of oil development. So, which country do you think produces the most oil? Which country do you think produces the most oil? Let's see if I can get some guesses in the chat. US, Canada, US, Saudi Arabia. Awesome, Canada. Okay, well, United Arab Emirates. Well, you all are know more than I did when I started this work, which is the answer is the United States. we produce about a fifth of the total world oil production, and we also are the biggest user of oil products. We consume about a fifth of the world's oil. So even though typically you might think of, Saudi Arabia, Russia is a big producer, Brazil, other countries in the Middle East, we are, and there's always a lot of talk about energy independence here politically as a political issue in the US, but we actually are the world's the largest producer of oil, and there's a lot of oil extraction going on in this country. In fact, crude production in the last decade, since 2010, has more than doubled. Natural gas production has gone up as well, although not quite by as much. And this has really been facilitated by technological innovations that have increased the scale of oil development and where oil development is feasible. So those technological innovations include directional drilling, where we're not just drilling straight down anymore, but we can drill in horizontal directions, accessing deposits that weren't accessible before, and high volume hydraulic fracturing or fracking, which is not a new technology, but it's being done on a much larger scale. And this involves injecting large quantities of water, sand, and chemicals into wells at high pressures to cause cracks and fissures in the shale deposits and allow the fossil fuels to flow out and up and out of the well. This type of oil development has a much larger footprint. Larger well pads are required. More equipment is needed to drill the wells and do the fracking. There's more industrial activity, more raw materials are involved, and a lot more waste is generated than in conventional oil extraction. And like I said, this has really opened up new areas for development that weren't previously feasible or economical, to the point where over 17 million people in the lower 48 now live within a mile of an active oil or gas well. Of course, in Los Angeles, you have a lot of oil and gas development going on, so that's not new in LA, but in other parts of the country, there's been a rapid expansion from no development to all of a sudden, hundreds of rigs and wells being drilled in communities. And so with the proximity of people to these activities, we worry about potential hazardous exposures. And some of the research that's been done, including some at UCLA, has shown elevated levels of several air pollutants near oil and gas well sites. Things like particulate matter, nitrogen oxides, VOCs, carbon monoxide. In places where there's radon, studies have shown the radioactivity of particles is higher. And this pollution can result from just normal venting. It can result from the transportation vehicles and equipment needed to drill or run drill rigs, dehydrators, separators, compressors, and from fugitive emissions from storage tanks, wellheads, pipelines, and related infrastructure. Studies have also shown that non-occupational exposure to oil extraction, so community exposure that is not necessarily workers, has been associated with cancer, altered immunological function, and other health problems. Most of these studies have been done in other countries where the drilling process may look a little different. Nonetheless, in the US, several epidemiological studies have now linked residential proximity, so living near a well, with adverse birth outcomes. And I'll talk about what I mean by those in a minute. Most of these studies, except for a couple of recent ones in California, have looked at gas wells rather than oil producing wells. One thing that hasn't really gotten a lot of attention, or where there hasn't been a lot of research, is flaring. And flaring is the intentional burning of natural gas during the drilling or production process. Nearly 5% of the world's natural gas consumption is flared every year, so a large amount of gas does get disposed of this way. And you may have seen or heard of flaring at refineries or industrial facilities. Usually that's an intermittent, unusual event, you know, an emergency measure undertaken to prevent some type of explosion. But in this context, flares often burn continuously for weeks at a time, even months at a time. Especially when in areas where natural gas is dissolved in the oil and there isn't a lot of infrastructure or incentive to try to capture and use that natural gas either on site or to bring it to market. And so in that context, it's considered a waste product and just burnt off. These flares can release several different types of hazardous air pollutants. And they can also impact the quality of life through light pollution, noise pollution, and, you know, they're not pleasant to look at, and it can induce stress or worry about the potential health impacts of living near one of these flares. So the aims of our study, and I'm going to talk about a project that I've done in collaboration with colleagues at USC that's funded by NIH, by the National Institutes of Environmental Health Sciences. And our aims were threefold. One, to just quantify and better understand the amount of flaring that's going on across oil-producing shale plays. Two, to try to understand how many people may be exposed to flaring and what those communities look like. And three, to determine whether exposure to flaring is actually harmful to pregnant women and babies. So we did an epidemiological study looking at residents near flaring sites and adverse birth outcomes. So I'm going to go through each of these at a time and then conclude with some like next steps and where we're headed next in our research and the broader implications. So our study site is the Eagle Ford Shale. This is a widely considered the most profitable shale play in the country. It's in southern Texas along the US-Mexico border or close to it, a mostly rural area spanning many counties, several dozen counties. And it's last year, more than 1 million barrels of oil were produced here every day. So it's a very productive oil play. And we estimate about 400,000 people live less than 5 kilometers of an active well in this area. These counties are some of the poorest in Texas and some of the poorest in the country in terms of the number of people living in poverty. And there's a lot of flaring that happens here because there's both gas and oil being recovered from the Eagle Ford, but the oil has a lot of gas dissolved in it, and because there's been such a rapid expansion in drilling, there isn't, and because the price of natural gas has been very low recently, there hasn't been the infrastructure or the incentive to build infrastructure to recover that oil, that gas, and to either use it on site or to bring it to market. So flaring is a pervasive practice here, and monitoring studies indicate that flaring is a significant source of nitrous oxides and volatile organic compounds locally and may be contributing to deteriorating air quality and non-attainment of Clean Air Act standards in cities like San Antonio that border this region. So one of the reasons that not a lot of work has been done on flaring is because there's not a lot of data on flaring. It's a mostly under-regulated practice. There's 2 air monitors, regulatory air monitors in this entire region. So there's not a lot of data on air quality, but it turns out that you can see these flares from space. This is a photo from the SUMI National Polar Orbiting Partnership satellite, a NOAA NASA satellite. You can see the big cities of Houston, Austin, San Antonio lighting up. This is Laredo and Corpus Christi down here. And this area circled in red is, there aren't a lot of big cities in here, just small towns, but it's lighting up, and what you're seeing there is the flaring from the oil development. So we used satellite data to measure flaring because of the lack of other data sources. And what we used is called VIIRS. It's data from the Visible Infrared Imaging Radiometer suite aboard the satellite that I mentioned. Began collecting data in 2012. It collects 22 different spectral bands at about a 750 meter resolution, so pretty good spatial granularity. And from this data, Christopher Elvidge and others have developed the NOAA Nightfire product, which detects heat sources at night, primarily relying on one of these 22 bands, the M10 band, an infrared band. So what can you detect with this M10 band? Well, at night, it's good at picking up infrared sources of infrared radiation, such as gas flares, which is, of course, what we're interested in, but also biomass burning, things like volcanoes, industrial heat sources will be picked up by this M10 band. But you're not going to pick up things like artificial lights that don't give off a lot of heat. So we use this data to try to figure out where and when flaring is happening. But first, we kind of take a couple of steps to make sure that that what we're picking up is really flaring and not something else. It helps that in our study area, there's not a lot of other potential sources of combustion, especially high temperature combustion, because there's not a lot of industry. There's no volcanoes. So we're pretty sure that most of what VIIRS picks up what most of the Nightfire product picks up is flaring. But we did take a couple of other steps to be even more sure about that. So the first was to limit to observations that are higher in temperature. So VIIRS Nightfire gives you nightly observations that include temperature and the approximate area of the combustion source, as well as the radiant heat. So we use that temperature variable to limit to the higher temperature observations, because biomass, when it burns, is at a lower temperature. So that helps give us more confidence that we're not picking up things like campfires or wildfires, trash burning, or anything like that. The next step is that we applied a hierarchical density-based spatial clustering algorithm to remove kind of isolated observations that weren't really clustered in space and time. So this picture here is of LaSalle County in Texas, where there's a lot of flaring and drilling going on, and the little white dots, these are well pads you can see across the landscape. And then the the red and green are VIIRS Nightfire observations. And this clustering process allows us to identify, these green ones that are kind of just hanging out here by themselves, as opposed to these red ones, which indicate like night after night, there's a combustion source happening at the same location. And so we're pretty sure that that's a flare. So we filtered out the green points, these isolated noise observations, so that we could have greater confidence that what we're measuring with this remotely sensed product is actually flares. And what we got when we did that was we looked at 5 years of data, so 2012 to 2016. We had 46,000 flares in our study area. That's what's shown on the left with the red dots. It's a little hard to see because a lot of them are overlapping with each other. So on the right is just the density of flares per square kilometer. And you can see kind of the hot spots that are lighting up there in red have more higher density flares. We also wanted to try to estimate how much gas was being burned off. So that's a little hard to do, but we used what data there is on on the volume of gas flared in the area. Regulatory data, this is self-reported by the industry, so we don't have a ton of confidence in it. And it's also only reported at the monthly time frame and at the field level, which is a bigger geographic area. But we used it to fit a variety of regression models where we use the flares as our predictor variables. And this is the best fitting model that we ended up with that allows us to kind of get an idea of the quantity of gas at the county monthly level that may be getting flared by these individual flaring events. So the results of all this you can read more about in this publication here. But like I said, we identified over 46,000 flares in the region over the 5-year time period. We compared the locations of these flares to the locations of permitted well permits. And that allowed us to determine that most of the flaring is happening at unconventionally drilled oil wells, which is what we would have expected. And we estimated about 4.5 billion cubic meters of gas were being flared over this time period. And that's about enough to power 2.5 million homes for a year. So it's a significant amount of gas being wasted. We next, like I said, wanted to look at, who are the communities living by who might be impacted. So to do that, we joined that flaring data I showed you with 2010 census data at the block level. That's the finest geographic resolution that census data is available. 2010 is obviously a little outdated, but we're still in the process of conducting the 2020 census. And we then summed the number of flares within a 5-kilometer radius of each block's center point. And we excluded urban areas in this analysis because basically 3 cities with more than 75,000 people living in them, because flaring is uncommon and often restricted in those urban areas. So that's Laredo, College Station, and Byron. And our main analysis focused on looking at the proportion of Hispanic or Latinx residents in each block. That's because they are, after non-Hispanic white folks, they're the second most populous group in the region. And we categorized the proportion of Hispanic residents in each block group into quintiles, so into 5 equal parts. And what we found when we did this is that Hispanics are more exposed to flaring in Eagle Ford than non-Hispanics. So the way to read this graph here is that among blocks with less than 100 flares nearby, so these 2 leftmost columns, about 20% of the population lived in a block that was primarily Hispanic, so 80% or more people identifying as Hispanic, Latino, Mexican American, or another Latinx ethnicity. So that's the purple, it's about 20%. But if you look over here on the right, these are the communities with more than 500 flares occurring nearby, and the majority of the population in those blocks lived in blocks with more than 80% of the population identifying as Hispanic. And you see something of a stepwise trend, which the more flaring that there is, the more people live in majority Hispanic communities. We also did some regression modeling to try to look at this more, some negative binomial regression models. And what is graphed here is an incident rate ratio, so and a confidence interval around our estimates. And so if you look at the pink and the green, these are our unadjusted model and a model adjusting for population density or kind of the degree of rurality. And both of those models suggested that the most Hispanic blocks, again, that purple group, the 80% and above Hispanic blocks, were exposed to significantly more flaring, so more than twice as much flaring as the least Hispanic blocks, which were the comparison, those with less than 20% Hispanic residents. And you see kind of a dose response function. The blue lines, or sorry, circles, are what we got when we additionally controlled for spatial autocorrelation in our data. Spatial autocorrelation refers to the fact that blocks close to each other are more likely to be similar to each other than blocks that are farther away, such that the modeling assumptions of the more traditional models are violated, the assumptions about independence between your observations. So if this is sounding too technical, don't worry, but the take-home message is that even when we accounted for that kind of spatial dependence in our data, we still saw that the more Hispanic blocks had more flaring going on nearby, although the effect was somewhat attenuated when we accounted for spatial autocorrelation. And the pattern is not driven by the fact that Hispanic communities have more wells nearby. In fact, we did not see that at all. Most of these estimates here are below 1, indicating that the most white blocks had more wells, the ones that aren't on this picture, so those with less than 20%, they had the most wells. So it's not driven by where drilling is happening. It's kind of independent of that. Flaring is distributed differently, and Hispanic communities are more impacted by flaring. And this might reflect, this is actually consistent with prior work in the Eagle Ford and in other parts of the country, and may reflect the predominance of white ownership of rural land, because 90% of recent unconventional oil and gas development has occurred on private lands. So the results of this work we published in this article about the environmental justice dimensions of flaring in South Texas, and our conclusions were, this is an environmental justice issue. Hispanic communities are disproportionately exposed to flaring from the oil and gas boom in the Eagle Ford. And our findings are consistent with a very long and established body of literature about the siting of waste facilities in communities of color. So prior work by my collaborator, Jill Johnston, shows that waste disposal wells used by the oil and gas industry in this area are also disproportionately exposed or disproportionately sited in communities of color. And in general kind of reflects this pattern we see where rural communities, rural America is sort of treated like a dumping ground for waste. And in this case, the waste disposal process of flaring. So let me just pause here in case there's any questions about what I've gone over so far. I know I've already talked for half an hour, so I'm going to try to get through the rest of this quickly, but if you do have questions, feel free to write them in the chat now, or else I will just keep going. Okay. So since I don't see any burning questions, I'm going to move on to the third aim that we had, which was about looking at prenatal exposure to flaring and birth outcomes. So why were we interested in this? Well, prior studies have linked living near oil and gas wells with an increased risk of having a preterm birth. That's a baby born too early, before 37 weeks, or babies that are smaller than average, so reductions in fetal growth. Preterm birth is a major risk factor for infant mortality and morbidity, especially the earlier you're born, the riskier it is. And pregnancy is kind of a critical window of susceptibility. So we're learning more and more that early life exposures in utero can have impacts on your health in childhood and even into adulthood. This is referred to as the developmental origins of health and disease. So a critical window of exposure and potential impacts to to infants that had been seen in prior work on oil and gas, motivated our study. And what we did to look at this was to use administrative birth records. So this is government collected information about births that happen every year. And from those, we assembled a study population of singleton babies between the years of 2012 and 2015. And then we got information on where the mom lived during pregnancy and assessed her exposure to flaring by counting up the dots that I've been showing you, the VIIRS flares, within 5 kilometers of her residential location. And we categorized that variable into either low or high amount of flaring based on the median level of flaring among the exposed women. And this is what our study population looks like. So it was about 22,000 births, a quarter were foreign born, 64% were identified as Hispanic or Latina, 70% were on public insurance, so less than a third were privately insured, and the overall preterm birth rate was about 11%. We looked at 4 outcomes: preterm birth, which I've already mentioned, small for gestational age, which just means you're smaller than usual for the sex of the infant and its gestational age, so less than the 10th percentile of other babies born at that point in pregnancy. We also looked at 2 continuous outcomes, gestational age and birth weight, so that we could detect kind of more subtle shifts in the distribution of the duration of pregnancy and birth weight. And what's shown in this table is in the high exposure group, so these women here that were exposed to the most flares, they did have a higher preterm birth rate, about 14% versus 10.5% in the unexposed group, slightly shorter gestational age, and slightly smaller babies. When we adjusted for other things using multivariate regression models, including all these variables listed here, things like how much prenatal, these are all risk factors for preterm birth, like how much prenatal care you get, whether you smoked, the mom's age, etc. We estimated that exposure to a high level of flaring was associated with a 50% higher odds of preterm birth. That's what this odds ratio of 1.5 means here, and about a 2-day shorter gestation on average. That's what this value is here. And when we additionally included the number of wells nearby, since wells have been linked to preterm birth in other studies, it reduced the effect estimate slightly, but they were still significantly elevated preterm birth rates in the high exposure group. We didn't see any relationship with the fetal growth outcomes that we looked at, small for gestational age or term birth weight. So these lines here are the confidence intervals around our estimates, and you can see they cross the null value, which is indicated with the red line. And we also, consistent with prior work, these are the coefficients from our models, we did see that, or the odds ratios derived from the coefficients, we did see that women with more wells nearby also had higher preterm birth risks. So there seemed to be an independent association between oil wells and between flaring and preterm birth. Because we were concerned about the environmental justice implications of flaring, we also looked at, we stratified by ethnicity to look at Hispanic women and white women separately. These were the 2 predominant groups in our study population, and we didn't have the numbers to be able to look at other groups. And we found that Hispanic women were number 1, exposed to a higher average number of flares. And that they also seem to be more vulnerable to the effects of flaring. So we saw a stronger association between flaring and preterm birth when we looked at Hispanic women alone. And in fact, we didn't really see much of an association. So this is kind of a null finding here among the non-Hispanic white women. And there's a couple of reasons we think this might be happening. It could be there's some kind of threshold effect, so you have to be exposed to a certain number of flares before there's any impact. Or it could be synergistic effects with other pollutants, because we know from the environmental justice literature that women of color are exposed on average to more a variety of different pollutants, so maybe they have higher exposures to other things as well. Or it may be related to social stressors that have been shown to amplify the effects of pollution or make them worse. So, for example, chronic psychosocial stress is associated with wear and tear on the body that can alter your immune function. So what we might be seeing here is like the physical toll of living in a racist and xenophobic society on women of color that results in greater vulnerability to pollutant exposures. We didn't measure any of those things, so we can't really say for sure, but this has been shown in some other work that women of color, for example, African-American women have greater reductions in birth weight associated with particulate matter pollution. So it is a pattern that's been observed in other studies. If you want to find out more, this is the publication about this work. The take-home points are that we estimated about 1,700 women were exposed to flaring within 5 kilometers during their pregnancy over the 4-year study period. Some were exposed to hundreds of flares during their pregnancy, and that exposure to a high degree of flaring, as we defined it, was, so 10 or more flares was associated with a 41 to 50% increased odds of preterm birth compared to no exposure, and that Latina women were disproportionately impacted. So from here, this is really the first study to look at flaring in preterm birth. So we do want to verify our findings in other populations. That's one of the next steps. We'd also like to do some, and have applied for some funding to do on the ground monitoring around flaring sites of air pollutants, because like I said, there's not a lot of monitors in this area. And so, we can't really be sure what it is about flaring that may be impacting pregnancy, whether it's air pollution or something else. And we're interested in looking at other additional health outcomes. And just to give you an idea of, is this only a problem in this one little region in Texas, or not so little, but this one region in Texas, we have also taken a look at, where else is flaring happening across the lower 48, and there are 3 real hotspots: the Eagle Ford Shale here, which is in the Western Gulf Basin, the Permian Basin here in West Texas and Eastern New Mexico, and then the Bakken Shale, or the Williston Basin up here in North Dakota and Montana. And you can see on this graph that flaring has been going, flares are the yellow bars. It's been going up over time. That is until recently, till the kind of crazy oil market collapse that we had earlier this year. We saw that's been going down since then, but the overall trajectory is more flares, more oil, and more gas in these 3 regions. And in fact, the hotspots of flaring are even more pronounced in these other 2 basins where we did not do our study, in terms of how many flares are happening in close proximity to each other. We did some mapping to try to estimate how many people might live within 5 kilometers of a flare, again using census data, but also incorporating this national data set of building footprints, which is shown here. So this is the UCLA campus, where you can see all the buildings outlined, and we used that to get a better idea of where people may live, because census blocks can be kind of big in these rural areas. So using that approach, we estimate over 500,000 people in these 3 areas that I showed you reside within 5 kilometers of a flare, and more than 200,000 live in somewhere that's had 100+ flares over this 8-year period that we looked at. And that's probably an underestimate because we use 2010 census data, and a lot of these places have experienced population growth since then. For example, like McKenzie County in North Dakota has doubled in population since 2010. And in all three basins, we found that people of color were more likely to live near flares, again, raising environmental justice concerns. So the Permian and the Western Gulf Eagle Ford Shale that I've been talking about, the majority of the population in these regions are people of color. And then in the Bakken Shale, it's a real hotspot of flaring, and a lot of it's happening on the Fort Berthold Indian Reservation, the Mandan Hidatsa Arikara Nation. One of the counties there has over 83,000 flares, and 93% of the residents live near more than 100 flares. So this does raise environmental justice concerns. And so I think this is my last slide here. You know, what are the larger implications of this work? Well, one, I think it's important to note that flaring is on the rise in rural oil shale communities and really does warrant both more research and more regulatory scrutiny. A lot of these communities face additional challenges to health. They're low income, high poverty areas. They're rural, may lack access to healthcare. And in general, rural US populations experience lower life expectancy than urban populations. And that gap is widening right now. And it's more severe for people of color. Satellite data can be, I think the second point here is that satellite data can be leveraged to objectively estimate flaring activity. So for things like this, where there's not a lot of other data available, remote sensing provides a real opportunity to try to understand what's going on and to estimate impacts to local communities. And third, flaring is an environmental justice issue. It's disproportionately impacting low-income, Indigenous, and other communities of color. And I think our findings reflect kind of a larger pattern, what Caitlin Kelly-Reif and Steve Wing have termed the urban-rural exploitation. So where resources like agricultural products and fossil fuels are extracted for rural areas, primarily for use and for benefit of urban populations. And then the wastes from associated with these industrial practices are also remain in rural communities. So ultimately, I think we should all care about this because it undermines progress towards more sustainable systems of energy. Because with a few exceptions like LA, the urban majority do not really experience the environmental and health consequences of this upstream side of oil and gas production. And so that undermines, you know, public support for efforts to make our energy more sustainable and less polluting. So I'll stop there. And thank you all for your attention. I also wanted to acknowledge my collaborators in this work at USC, and I'm happy to answer any questions.
Okay, thank you so much. Would the first three questions be done by students, please? So a student, please, if you were sure.